All right, guys, this is 5.1, average rate of change in slope. So we're getting into the specifics of linear functions here for Algebra 1. So definitions, a couple definitions here. We've got rate of change is defined to be the relationship between two changing quantities, like time versus height is one we've seen. So it shows the relationship between two changing quantities. Miles per hour would be another one. Feet per second, that type of thing. The slope of a line is described to be the rate of change. It's the vertical change over the horizontal change, also known as the rise over the run, and can be calculated on an XY coordinate grid with points as m equals y2 minus y1 over x2 minus x1. Those little 1s and 2s are what we call subscripts in algebra, and they represent two separate coordinates or points. Like x1, y1 is one coordinate, x2, y2 is the other coordinate. So once again, pause the video if you need to get this written down. You're going to be using this slope formula a bunch. Let me get into some examples here. All right, the first one, finding rate of change using a table. We did this back in chapter 4. It says the table shows the distance a band marches over time. Is the rate of change in distance with respect to time constant? Well, let's look at the table here for distance. We go from 260 to 520. So how much do we go up? We subtract 520 minus 260. What do we get here? So 260, 360, 460, looks like 260. And then going from, so this is 260 here. And then the difference from 520 to 780 is also 260. And then from 780 to 1040 is also 260. Make sure over here we're only going up by 1 each time, otherwise this doesn't quite work. You have to fill in the blanks. So the fact that we're going up by 1 minute on the time, or x part of the table, and then on the y part of the table, we're going up by a constant rate of 260, we can say that the rate of change, or slope, of the equation is 260. So we would say the rate of change is equal to 260 over 1, where 260 represents the feet and 1 is the minute. So every minute the band is marching 260 feet across the field. And so that we would refer to as our slope. We know this is linear because from the table I can see we're going up by a constant amount each time. All right, problem 2. We've got finding the slope using a graph. So the last one we looked at a table to get the slope, and the slope was the constant change in y, or the rate of change in y. When it comes to finding the slope on a graph, we can start at one point, like they're doing in part A. They're starting at the point -2, -1. And from there, we're going to march up and over, only at a right angle, to get to the point 1, 1. So I go up 2 units and right 3 units, which gives me a slope, m, equal to 2 over 3. The 2 is the up or down amount, or the vertical rise, we called it, and the 3 is the right or left amount. And so typically what we'll do is we'll treat maybe a negative number as a going down, or a negative number on the bottom as a going left. We've got to be a little careful with that because we can only apply the negative either to the top or the bottom, not both, unless we want to make it a positive slope. So we would say this is a positive sloping line. It's going up from left to right. It's positive sloping right here, going up from left to right. And so we want to make sure that the sign of the slope here matches that. I have a positive 2 over 3 because this slope is going up as I read it from left to right. It's like climbing the mountain. Whereas over here we have a negative sloping line. And we're going to figure out the slope of that by going from the point -3, 2. From the point -3, 2, we're going to go down 4 units. So we'd say m equals down 4, we'll go ahead and apply the negative to the 4, and then right 5 units. Keep that positive. And so my slope there is a negative slope. It's negative 4 over 5. Just tells me the rate of change, the rate at which we're going down and over to the next point. So that is slope from a graph. All right, third one is finding a slope using 2 points. I gave you the formula at the beginning, m equals y2 minus y1 over x2 minus x1. And I should be saying sub. It's y sub 2 minus y sub 1 over x sub 2 minus x sub 1, because these are subscripts. And the way we usually label it is the first point you encounter in the problem, you usually call x1, y1. So remember, the first number in the coordinate pair is x, and the second number is y. The second number we come across is usually labeled x sub 2, y sub 2, although it really doesn't matter because you could switch up the order of those and it won't matter. They don't know the difference of whether they're the first or second coordinate. So you could switch them up and label them so that negative 1, 0 is x sub 2, y sub 2, and 3, negative 2 is x sub 1, y sub 1. It'll look different when you plug it into the formula, but you will get the same solution. So we've got m equals, okay, y sub 2 is the top left of this formula. Y sub 2 is this guy right here, negative 2. So I'm going to plug in a negative 2 for y sub 2. And I'm going to put parentheses around it. It's always a good idea when you plug in a number for a letter to put in parentheses. We'll see why here in a minute. But negative 2 minus y sub 1 is 0. And then on the bottom, I've got x sub 2 is 3, so I'm going to replace x sub 2 with 3, and then minus, and in parentheses, I'm going to put in a negative 1. Right there we have a minus sign in the formula, and then a negative sign that we're using for the number we're plugging in, this x sub 1 right here. So that's where the parentheses are kind of nice. And then we simplify this. Negative 2 minus 0 gives me negative 2. 3 minus a negative 1 becomes 3 plus 1. This minus of negative is plus. So I've got negative 2 over 4. And negative 2 over 4 reduces down to negative 1/2 because 2 goes into this once and into this twice. So my slope using the formula is negative 1 over 2. We'll practice some of these in class as well. All right, last one. So we talked about, let me go back here a little bit. We talked about a positive and negative sloping line. Let's go back to here. So we have this positive sloping line here, negative sloping line here. What about slopes of lines that are vertical or horizontal? We talked about those. So here's an example of one that's horizontal right here. Horizontal slopes, it's like the floor. If you think of, if I were to ask you, what's the slope of the floor? Hopefully you'd say, well, the slope of the floor is 0. You know, it doesn't tilt up or down, it's just level. So we would say the slope is 0. Let me demonstrate that here in a few different ways. If I were to use the graph, I would say, well, I'm going up 0 here, and I'm going over from this point to this point 1, 2, 3, 4, 5 units, 0 over 5. And so that would be a slope of 0 because 0 divided by any number is 0. Another way to think about this would be with the formula. If I use the formula, I would have m equals, just erase this here so you can see it, m equals y2, which would be this guy right here. Here's the y2, so 2, minus y1, which would be that other 2, over x2, which is 2, minus x1, which is negative 3. So you'll see I get 0 on the top, 2 plus 3 on the bottom, which is 0 over 5, or 0. And so horizontal lines, you can memorize this because it doesn't matter if the horizontal line is there, or here, or down here. It always has a slope of 0. Just think of the floor. Okay, the floor is level, slope is 0. Now, this other one, the vertical line, okay, so you could be facing the wall. I'm facing the wall right now, a vertical wall. I am not going to climb the vertical wall. I'm not Spider-Man. What is the slope of that wall? Well, we say the slope is undefined when it's straight up and down. Slope is undefined. Okay, we got to be careful with saying no slope because that might get confused with the slope of 0, like the floor. But the slope is undefined. Let me just show you here. If I were to go up, I'd go up 1, 2, 3, and then I go over 0. You may have learned that 3 divided by 0 is an undefined expression, and so slope is undefined right there when it's vertical. And that's how you'll describe it. All right, thank you for watching. Hope that helps. That's 5.1 slope using tables, graphs, and a formula.